Thanks, Daniel. Well, hearing a pin drop in the Superdome packed with thousands of screaming fans would be an easy task compared to observing the tiny gravitational waves that permeate the universe. At LIGO Livingston, nearly all of Earth's noise must be filtered out to have the slightest chance of detecting these elusive displacements. And these Nobel Prize winners are up to the challenge.
We made our first triple coincidence detector with the Virgo instrument. We did the detection of the binary neutron star with the electromagnetic follow-up and got the Nobel Prize in physics. That's a hell of a couple of months.
In part one of our visit, we described the gravitational waves and how LIGO Livingston can detect displacements in the universe down to 1/1000th of the size of a proton. But they need to get a good lock on the laser interferometer and have a baseline of all of the other noise in the world.
It's the wind that causes the interferometer to shake, but we also get affected by storms, even storms out in the Gulf or out in the Atlantic, 300, 400, 500 miles away. The change in pressure and the waves, pushing on the Earth's crust will actually move the ground motion here so fast that we can't keep up with it anymore.
It's called microseismism. They monitor the entire complex with sensors and microphones to measure everything normal because the laser has to be locked. Any movement can throw it off, and those movements can come from earthquakes, oceans, and even us.
In the 1 to 10 hertz bandwidth. Overnight it was quieter, and this is human activity, traffic, sometimes trains. That will drop off again, when people end up going back home and going to bed.
It's essential to be accurate.
Some people call that the scientific discovery of the century, so you want to be right about it.
There's an interactive learning center at the location. They've seen an uptick in field trips since their Nobel Prize win. There's even an opportunity for the general public to visit.
So we have a tour the third Saturday of every month.
Dr. Oram says the future of the research could be unlimited.
There are things we're going to discover that are as yet unknown or even unimagined.
And they'll need help making the future take shape.
Stay in school, study maths and physics, even though it's hard, because that's the future. That's what we need, people who are very curious, know maths, willing to work hard, and have some imagination.
It really was a fascinating facility, and the work there they're doing is captivating. If you'd like to learn more, you can visit their website, ligo.caltech.edu/LA, or you can visit their Facebook page, LIGO Livingston. And Tracy, after going there and then, you try to wrap your mind around how far away these things are in space. There's a couple of nights after I went to Livingston, just looking at the sky and when he says you have to have a lot of imagination.
Yeah.
It's mind-boggling what they're doing at that facility, and they win the Nobel Prize.
That's the thing I think that's like, wow. We have a Nobel Prize winner right here in the state of Louisiana.
Right, and we were trying to figure out if there were any other connections to Louisiana with the Nobel Prize, and he says he wasn't aware of any, at least in physics, but he was not aware of anything, being connected to Louisiana with the Nobel Prize. Yeah,
so cool.
It's neat. So every third Saturday, the public can go visit, but they do field trips during the week for schools.
But you got, like you were saying
get in there
earlier.
early. Yeah, I got to call them or get on their website, and all the information is